about something. People who are registered, you will get the slide deck and some of the examples I'm going to be demonstrating today. Just so that I kind of understand the audience. How many of you would say that you are primarily in finance, but are not coding on a regular basis? You mostly do like investment decisions or kind of do financial investment planning. Okay. How many of you are quants? You have to code. How many of you are machine learning enthusiasts interested in the finance side of things? Okay, so I think we should have kind of, next time we'll do like some kind of a color coding kind of a thing so that, all the finance people wear greens and all the machine learning folks wear red, so you can like, interact and like discuss like what interests you. This particular meetup was kind of founded on the principle of making sure that we kind of have the intersection of multiple disciplines. Because as you know, data science and machine learning have been around for decades now. People on the computer science or engineering side of things have been doing a lot of machine learning and data science for various kinds of problems. Quants and the data scientists in the financial industry have now started to adopt many of these techniques for investment decision making. And there are a lot of questions on what these techniques are and how are they relevant for the day-to-day things you kind of work on. And on the technology side, a lot of machine learning specialists are thinking, well, we know our math, we know our machine learning algorithms. What are those use cases we can apply these techniques? And they're more interested from the financial use case side of things. So when we founded this company, way back in 2013, so we are 5 years old officially. We primarily focused on working with quants and helping them kind of realize the power of computation, the power of data science, the power of machine learning, and bringing that into their work practices. So we founded a couple of programs. One is what's called the Analytics Certificate Program. I'll tell you a little bit about it as we go. Primarily to help people who are more on the finance side of things to adopt any of the analytical techniques, to kind of learn some of the data science techniques, the coding languages, the interpretation techniques, and how do you actually apply that in the financial side. And then we are starting the FinTech certificate program. How many of you are FinTech enthusiasts or doing something with finance or FinTech? Many people are now interested in FinTech. So we're starting the certificate program in FinTech, and I'll talk a little bit about it. And many of the questions we get on a regular basis. So we're kind of codifying that intelligence and we're putting together a platform called the Q Sandbox, the Quantuniversity Sandbox, which I'll give a brief demo of. So we have some of our engineers back at the room who are helping out generously in their aid, so they'll also be able to help out with some demo aspects. So a little bit about myself, since most of you don't know me. I have been living in the Boston area for close to 20 years now. I went to grad school here. I worked for a bunch of different companies. Went to Northeastern, went to Babson, and worked at Citigroup as a quant. Did a lot of fixed income analytics, like most of you, kind of working with bonds and working with Bloomberg and working with a lot of data systems. And then I joined a startup called Indeca, which got bought over by Oracle. And then I worked for a company called MathWorks because they were doing a lot of interesting things on the machine learning side of things. And they wanted someone in the financial services world to come down and help them set up their consulting expertise and practice out there. So for more than 5 years, I was leading financial engineering consulting projects at MathWorks, primarily working with large hedge funds and banks and things like that. At that point, I was kind of realizing a lot of people are now asking me to do a comparison of Python versus MATLAB, R versus MATLAB, and how do you kind of compare the open source features in a particular platform versus what we sold as an enterprise offering. And I had to basically, learn MATLAB, learn Python, learn R to basically do the due diligence and then do the compare and contrast and tell them, look, at this stage of your, pipeline, the way you're building it, you require a lot of support. You need to go to MATLAB, or you guys have really smart, engineers and scientists in your office, so you should probably think about just getting an open source solution if cost is a concern. So we did a lot of those kinds of projects, and then I said, well, we need to set up an advisory. I left MathWorks in 2014. And then I kind of went back to my alma mater. So I teach as an adjunct at Babson and also at Northeastern. I've been doing more teaching at the Northeastern University in the Information Systems program. So I primarily run two classes. One is called a data science class. methods of data science. It's like a 16-week offering. So students come in with like absolutely no coding experience in Python or R. And by the end of the program, they're writing machine learning and data science applications and go and work for various companies. And that has branched out because of a lot of enhancements in the field to a cognitive computing class, which is primarily focused on some of the deep learning, reinforcement learning, and some of the AI aspects as you see, building Alexa skills, building chatbots, interesting natural language processing applications. So every year, close to 200 plus graduate students take my classes at Quantuniversity, and I also take the lessons learned because students are very proficient in kind of learning new platforms and applying them to business use cases, and they teach me new things they have learned as they experiment things. And I basically can learn from my students' experiences, and I take it to the enterprises and I kind of share what I've been learning, because this is kind of a very fast and changing field. So you have to constantly be plugged into the ecosystem to understand what's actually happening. So, we have kind of codified a bunch of different programs. One is called as Explore, for people who have absolutely no coding skills, want to get the 60,000 foot views. So we call them the Explore series of workshops. Experience are like topical ones. We're doing a natural language processing 2-day workshop next month. We're planning a blockchain class, a 2-day workshop again. Those are thematic workshops. And then we have an Excel series, which are typically 8 to 12 week programs. We bring in people who are interested in kind of spending 8 to 12 weeks, kind of learning different programming language and working on case studies. So at the end of the whole program, they build a portfolio of case studies so that they can either use it in their context or they can take it to a function of tomorrow. Okay, so just some dates. The first time in Boston, we are doing a data science for finance summer school. We did an online survey. A lot of people were interested. We're kind of observing that there are no real summer schools for investment professionals. So it's like a 3-day workshop, primarily to kind of get you oriented. So that's going to happen on July 24, 25, 26. And the next month, there's going to be a fintech summer school, primarily 3 days of learning different business models of fintech and understanding the various business practices. Okay. So that's a little bit about our organization. And today, my goal is not to kind of give you the syntax of Python and tell you why pandas is the best way to deal with data sets, or to tell you why you should be using keras or TensorFlow or any of these packages. My goal is to kind of get you an orientation on when people talk about data science in finance, what are the kinds of things they're talking about, what are the drivers out there, and kind of focus on machine learning, because when people talk about machine learning, everyone has their own definition of what machine learning is. So I want to kind of give out like a pipeline approach or framework-based approach on how do you actually build out machine learning pipelines, so that you have an idea of what it means to build a machine learning application. Okay? And I'm going to talk about some, especially in the financial side of things, the kinds of things you need to be aware of when you talk about machine learning, because it's not, if it works in computer vision, if it works in autonomous driving vehicles, doesn't mean that it should work in finance too. So you have to kind of understand from a financial perspective the kinds of gotchas which are out there. So I kind of summarize like the 5 things and give you a little bit of case study, like the kinds of things people are doing in the context of machine learning, and I'll give you some code and case studies so that you can at least appreciate, even though you've never coded in Python before, you can kind of appreciate what does it mean to write applications. And then we'll demonstrate some of the things we're building and love to get some feedback on how we can potentially enhance this in the context of use and box. Okay? And this one's, these meetups are very informal. So, I would encourage you to kind of, stop me and ask questions. But also, I'll have to be contextual. We have like an hour and a half, so I would like to present like 111 slides. So, if there's a very specific question and it's going to detract me, I'm going to potentially ask you to leave me afterwards and you can answer those questions. Okay, so let's kind of start out with a couple of stories, because I love stories and analogies, and that's how I learn. And especially if there's a new concept, rather than just kind of getting into the equations, getting into the formulations, and trying to understand all these aspects, you need to kind of contextualize all these problems. So my first experience is in a trading show which happened in Chicago last year. And I was invited to be one of the speakers, so I went out there, and there was a panel on machine learning, and there was this company, and many of you must have heard this pitch from various vendors coming and pitching you machine learning-based, signal signals as a data feed they would be selling to you. So there was this company which was selling machine learning-based signals, and they kind of talked about how they've been back testing and how their signals were better than some other things which are out there. And I was fascinated by all the data which they were presenting, primarily in PowerPoint format. And then afterwards, I had a chance to talk to the founder. And basically, I was like, so can you tell me a little bit about the kinds of techniques you are using in machine learning? And he assumed that I was one of the quants out there, didn't really understand technology aspects. I was like, oh, those are really complicated machine learning techniques we are using. Deep learning, we're using reinforcement learning, we're using a bunch of different things. So I can't give you all the things, but these are all the things we're kind of using. It's like you can be a little more specific because I kind of understand. I've been prototyping some of these solutions. Same kind of answer. We can't reveal our trade secrets because we're doing something very interesting. And then I kind of started to saying, look, I'm teaching these techniques and not these things. My students really implement these techniques, so I can understand. I'm not going to just take your idea and go and implement it tomorrow. So you can talk a little more in general. The person wasn't able to read it. It's a black box, and I won't be able to share much of that. So the point is, a lot of companies are now just taking the hype and then trying to sell machine learning as a panacea or better than what you are currently used to. So you need to be aware of that. And then you have a lot of marketing buzzwords. Data is the new oil, AI is the new electricity, and you kind of hear these motivating speeches on TED or some of these YouTube presentations and think, I can just bring those techniques, apply them into your investment practice. So how many of you are actually using deep learning for investment decision-making in your companies? Okay. I'd love to talk to you more if you can reveal a little bit about what you're actually doing. Not in the context of the trade secret, but very few people are actually using some of these techniques. And that's because, first of all, there's a knowledge gap. Some of these cool technologies are still being developed, and they work in very specific scenarios. So you can't generalize those scenarios. So you need to be really doing the due diligence to understand what actually works and in what context it will work. So how many of you, yes please?
What would you categorize TensorFlow as?
It's machine learning framework. We'll talk a little bit about some of the, I'll kind of generalize what TensorFlow is. How many of you were told to learn Python because you're interested in learning data science, machine learning? Okay, so there was a conference recently, and that was the whole thing. If you're interested in machine learning and AI, you need to learn Python. So that's like saying if you need to kind of use electricity, you need to understand Ohm's law, or you need to understand Ampere's law, and you need to really understand what's actually happening in the equations and things. That's not really required. You need to really understand how do you actually contextualize and bring these solutions and hire the right kinds of people. Right? And the third one is there are a lot of snake oil vendors, and I was kind of going into the same thing. So please don't believe someone teaches us that day or a week or a month you're going to be a data scientist if you've never done it before. It requires thought process. Many of the quants kind of appreciate that it requires a lot of training and practice and experimentation and heuristics and kind of doing the due diligence to really understand techniques and kind of confirm your hypothesis. Very similar aspects in data science and machine learning. You won't just be able to take a black box solution and just because you know TensorFlow, just because you can structure a neural network doesn't mean that you will be getting answers which potentially wasn't available in your solutions. A couple of stories. So as you know, everyone's here because, yes please.
Sorry to interrupt you. Actually, in what terms Python is better than R?
It's a very specific question, but we'll kind of talk a little bit about the basic thing is R was developed by social scientists. So if you are trying a new algorithm or someone in the research world has put together something, so you may find a package in R. Python is a generic programming language just because of the adoption by Amazons and the Googles of the world. It is becoming much more prevalent, and many of the deep learning and machine learning packages are now supporting Python. So if you are starting from scratch and you want a package which does something, you may find an R package. There are more than 10,000 R packages and more than 10,000 Python packages. You may find an R implementation faster than getting a Python implementation. Okay? But now kind of things are becoming much more robust. You have both platforms kind of, and at least you have bridges you can interact with each other. Okay. So you see a lot of companies doing the hiring, right? Like when we talk about skills, I was kind of hearing some of the MBA programs are now introducing many of the data science and quant classes because the traditional business programs are not gearing students enough to the skills of what the industry is requiring. And we did a workshop on NLP and neural networks in New York last year, and we had 12 data scientists, each one having a PhD from JP Morgan, attend our workshop. And they were basically given a task of kind of leveraging all their text documents and kind of building systems so that they can gather intelligence and provide it to their analysts through platforms. So there's a lot of interest, not just in the traditional investment side of things, but also a lot of on the support side of how do you actually build these and bring these solutions into your workplace. So what it means is you have to kind of, first of all, identify a particular use case of what you intend to do, and then pick the various platforms and the tools you need to kind of build out these solutions. Now, a lot of people talk about AI, and when you kind of define what these terms are, there's a lot of blurring of AI and machine learning and data science. Most people kind of do not have a clear definition of what it is. So I would recommend reading this FSP document, which kind of, at least attempts to clarify some of these terms, and it's free, and I've given you a link which is downloaded. It's like 20 plus pages. So AI is the theory and development of computer systems able to perform tasks that traditionally have required human intelligence. Though AI is a broad field, machine learning is a subcategory. So you have to kind of understand that everything is not AI. Anything which requires human intelligence or anything which mimics human intelligence could potentially be an AI system. Just because you are learning from data and you are kind of having a data-driven technique doesn't mean that you have an AI-based system. The other aspect is, when you talk about, what does a quant actually do in the financial industry, and the kinds of skills people are actually asking for today. These are some of the things you must have heard of. When you were taking your undergrad and grad classes, these are the kinds of things you potentially were exposed to. Stochastic models, factor models, optimization, risk models, derivative pricing, trading strategies, etc., etc. Right? A lot of people who are working towards their graduate programs now are mostly learning skills on that side of the spectrum. Okay? So you can see things like predictive analytics. So how do you learn from behaviors you have seen in the past and predict what may happen in the future? RPA, robotic process automation. I have built systems even in my MathWorks days wherein you were having a bunch of PDF files, you would scrape these PDF files, take some elements out of these PDF files, put it into a database, use those elements from a database, kind of put it into your model, that's going to generate a signal, use that, and you build out all these elaborate pipelines. That's all data science. We were using those terms in the IT world, basically saying these are my specifications. I do not want to be spending 2 or 3 hours kind of scraping these numbers from PDF files, putting it into a database, and then doing my decisions. I want the whole thing to be automated. So that's basically building a lot of systems, what's called as robotic process automation. And natural language processing, most of our data has been structured, clean in databases, rows and columns, which are used to Excel-like data sets. But there's a lot of influence of NLP or natural language processing or text-based processing. So that's a new thing which people are kind of implementing. Deep learning, I'll tell a little bit about deep learning, but the key point here is, things like neural networks, which was there in the 90s, could not scale well. And now you have the technology, now you have the frameworks like TensorFlow. So you have a lot of software, you have a lot of hardware. There are some interesting problems which humans can't design elegant algorithms because you're doing the feature engineering, you're doing the factor selection. And many a times you have to make assumptions on linearity, assumptions on polynomial ways in which, or step functions, or ways in which you're going to see inflections, and you're trying to model these in a statistical sense. When you're building deep learning systems, you can potentially generalize it and just kind of provide the structure of the network, and then let the algorithms decide what could be the mathematical parameters which would fit that particular case. And then graph analytics, because you're trying to now understand relationships, contagion relationships, what happens if there are n degrees of separation between what you're observing and what else is happening. How do you actually model those kinds of things? marketplace, who are the influencers in the marketplace, and what happens if there are like 6 companies all networked in a particular way and something happens to a key supplier or a key distributor. So those aspects are primarily done in the context of graph analytics and how do you use network analytics to kind of use these aspects. Chatbots, in the context of customer service, I don't know if I can specifically name companies, but there's one particular insurance company in New York which hires at least 6 to 10 Northeastern co-ops every semester. And they are building a whole process automation system, kind of letting go of their human intensive workflows with automated systems so that you can use most of your resources to do other additional analysis and collect data on how people interact with the system, how you can gamify and engage more people. So that's kind of going into the fintech side of things. When I went to another company, this is not the same company, Liberty Mutual, and the agent told me like, well, would you want to get one of these, which will guarantee you 5% reduction in your premium for sure, but you need to put this in your device in your car and you need to run it for like 3 months. And we are going to be collecting all the data on how often do you brake and how often do you kind of speed up, and you're going to collect all the data. It's going to help us kind of design insurance premiums in the future. So traditional things which were mostly based on simulations and kind of asset liability matching. These are the premiums we're going to be collecting. These are our liabilities. We just need to match them one. So that model is changing. A lot of companies are thinking about new and innovative ways of which collecting data, processing the data, and then kind of building business models out of it. Sentiment analysis, any event trading folks in here? I remember when I was doing a project for one of the energy traders in Houston. So I had to build a system which would basically Thursday at 10 o'clock, there would be a particular economic indicator, and we had to basically build systems and algorithms which would scrape that website because that was the only way you could collect that particular metric. So we were constantly pinging that website, and we would get blocked if you pinged more than 50 times, in a second. So we had to basically create this network of systems throughout the country, and basically have each one of them ping the website, the government-run website, get that metric at 10 o'clock, pass it to our algorithm, make the investment decision whether we're going to buy or sell based on an expectation. And by 11 o'clock, everyone would be heading down to the nearest taqueria to have nachos and queso. The trading was done within the first hour, and then the next week it was kind of optimizing and building new algorithms. So event-based trading, it's all about getting that signal because there are many more people trying to get the same signal and making decisions. I'll give you a case study, another scenario. So that's a lot about now that we are in the tweeting world, so we need to have something to listen to our tweets, otherwise you're going to be lost. Because if you're waiting for a data feed which may come like 15 minutes later and you already had a tweet 15 minutes ago, the opportunity for trading is gone. So you have to kind of build those analytical systems so that you can capture these sentiment analysis factors, or you have to kind of scrape certain things and put up. And there's a lot of talk about alternative data. There's a lot of people trying to use data feeds which were never available. I still kind of look at my Bloomberg certifications and see all the data feeds I would get from my Bloomberg and traditional databases we had. But now you're getting all kinds of signals. A good friend of mine, Anish, he's at Cargometrics, and he's kind of tracking, their company tracks. Anyone come from Cargometrics? I don't know if I'm misrepresenting the company's products. I think they're collecting analytics on ships in the ocean and then making investment decisions based on the number of ships, location, and all these aspects. And there are already some interesting applications about the number of cars coming out of the production line using satellite imagery. A couple of students of mine in the last semester got a data set from an insurance company, and they were basically looking at the roof types of buildings and building out a data set, because insurance premiums are dependent on roof types in hurricane-prone areas. So if you have a particular kind of a roof type, it's considered more stable compared to other kinds of roof types. So there's going to be a premium adjustment if you have the wrong type of roof type. Even though you haven't disclosed it, there's no data on any of your systems because of satellite imagery. this company will be able to provide you based on the geolocation what kind of roof type you have. So a lot of interesting applications in the financial world on these kinds of aspects. Cooler, and you can kind of say that I'm not restricted to some of the core things, but there's still a lot of skepticism on what's feasible, and that comes with any of the new techniques, and you have to think about like how do you vet out these techniques and understand it to a level when you are going to be able to make those decisions for whatever purpose you can be using. Okay, so I want to kind of talk a little bit about why we're talking about machine learning and AI. I mean, like some of these concepts are not new. I mean, everyone learns regression, when you're kind of doing your statistics for one class. Everyone learns about models when they are kind of building out even an engineering class or a statistics class or a social sciences class. So how do we kind of factor all these aspects, and why are we talking about all these interesting things? Right? So first of all, you must have heard of big data. Everyone talks about. I'm going to stop talking about big data now that deep learning is more popular than big data. It's kind of interesting. 3 or 4 years ago, every big data conference was sold out. Especially if you wanted to. They were selling tickets at premium, like $3,000, $4,000 for like a 2-day conference on big data. The whole thing was like everyone trying, the vendors selling snake oil. Oh, you're going to be putting a bunch of Hadoop clusters. And I must ask this question again. How many of you have found real value in your big data implementations? Gotten the ROI? Love to hear some of the use cases, but again, most of them were thinking that that was a solution to the problem they did not have. They thought that the big data solution would be solving their particular problem, but it has not realized. The smart people, the people who really had a big data problem found value, but a lot of times, they just went with the flow and implemented big data solutions, and they're not really getting value out of those implementations. But the key thing to notice, there is volume. Obviously, we have a lot more data, and there's variety. You have tweets, you have structured data, you have geospatial data. You have a lot of interesting kinds of data sets which you can potentially use. The velocity, obviously, we're not getting data overnight, like once a day kind of a thing. You are getting data more or less multiple times. The data may be refreshed, or if you're working in the trading area, you can see data which you can't even capture. You're potentially getting a lot more data which you can actually process. And then the veracity, which is becoming an interesting problem, because how do you make sure that the data you are getting has truth in it, and you can trust that to make your investment decision? Because many times, there are all these fake news phenomenon, but if you are trusting a particular data source and you trusted something to make your investment decision, you then realize that the data is not accurate. So you have to factor a lot of things when you're building these data science and data analytics kinds of systems. The second thing is a lot of interesting frameworks. In the big data side of things, we had a lot of innovation. Many of the Apache projects were basically targeting specific problems. And then Apache Spark. Any Apache Spark users? You guys use Apache Spark? Okay. So Apache Spark kind of addressed many of the challenges in the Hadoop ecosystem, and have a platform which will actually help you kind of target certain applications, both on the streaming side of things or on the text side of things. So it basically made big data platforms more accessible. And then, we had a question about deep learning. A lot of time and energy has been put in by a lot of researchers now on figuring out what's the best way you can leverage all these data sets, especially in the modeling context, and can we use neural networks and with aspects of the nuances in the problem we are trying to address, can we leverage some of these solutions? So you can see a lot of different frameworks, depending on where the platform started. For example, there was, let's say, Theono. Theono started out as a research effort at the Montreal labs, and they basically built out a Python implementation so that you can leverage some of their algorithms, summation networks, algorithms, and things like that. And then Google heavily backed TensorFlow, which is an open source project, and it is also a way in which you can invoke various kind of deep learning algorithms. Then you have MXNet, which is heavily backed by Amazon, and you have CNTK, which is heavily backed by Microsoft. So you see all the big players are competing heavily to kind of have their say and then build out these systems, and which is kind of amazing because most of these are open source products, but they are being backed by a lot of enterprises. So the product ecosystem is maturing. So it gives you the tooling, which may be hard to kind of get if you are an early adopter or researcher who does not have the capability to kind of get the GitHub builds and then kind of build out new implementations. But there are also accessible ways in which you can access people. For example, there's Keras, which is a high-level programming language where you can structure and focus on the network architecture and let the compiler kind of decide what's the best way to implement it. So what happens is you can decide whether you want the code to run on TensorFlow, you want the code to run on CNTK, you want the code to run on Hero. You can switch the backend to just a configuration parameter and have more or less one code base, and then you can try it on different frameworks. I use Keras in my classroom when I teach it because you can focus on the modeling side of things rather than implementation details on, do you have your matrix structure right? Do you have all the parameters kind of put in the right places? How do you test out whether you are actually needing to, invert a matrix or pivot a matrix or present the data in the required formats? So as you can see, there are a lot of things you need to worry about when you're kind of building out these machine learning systems. And I don't want to overwhelm you. I just want you to have an idea, the kinds of things you need to be aware of when you're building these kinds of systems. Then you have hardware. It's not just software you're looking at. You have to think about where do you run it, right? Most of you have cell phones which are more powerful than probably $2,000 or $3,000 system you could buy in like 2005. The processing power is accessible so much now that you can either buy a system or you can rent it for peanuts. For less than $1, you can get a really good system on Amazon. You just need to be able to log in and requisition the right kinds of resource. But you can rent your hardware and test it out before you can actually implement it in your enterprise. Right? And then there are specialized hardware for specific kinds of problems, especially in the context of AI and deep learning, which requires a lot of matrix calculations, which requires a lot of gradient computations, which requires a lot of experiments or heuristics so that you have to run the same experiment multiple times. If you're trying to do machine learning and you need to do cross-validation, you want to try out ensembles, you want to try out different machine learning algorithms and choose one model versus the other. There is no one optimum model you are running and kind of done with it. You are basically trying out multiple things. It's a search and then figuring out which is the best option to go for. Right? That's where you need the power of hardware. And many of these systems are designed so that you can leverage the power of the hardware and then be able to scale it on the cloud without you having to kind of do it in a sequential manner on your CPUs. So that's where companies like NVIDIA come in, where they can give you $500 GTX 1080, whatever you're using, and then say TensorFlow, here's my GPU, this is where I need you to run your computations are and get that speed up. Or you can go into the cloud and say, I want this particular machine with a GPU so that I can basically leverage these aspects. So when we're talking about all these aspects, so I'm kind of giving you the big picture on the kinds of things people are talking about when they're talking about machine learning, AI, and data science. And it starts becoming overwhelming. As a decision maker, where do you start? Right? So again, I thought that this was kind of a nice way in which you can look at. There are the supply factors. Obviously, you have a lot of technology available. You just pick up the phone and call a vendor. They're going to be there tomorrow morning, ready to give you a demo. You have a lot of infrastructure available. Hopefully, the economy is going to support that. You have a lot of budgets. You're not constrained. You can potentially try out new infrastructure, try out ways in which you can apply some of these new techniques. But then you also have the demand factors. People are now questioning, well, should we just do it because everyone else is talking about AI and machine learning? Should we just basically look at, if our competitors are doing it, should we also be implementing some of these solutions? What's the value add? What's the ROI? People are now starting to really question. And there are a lot of other aspects too. wherein there is regulatory concerns. We don't have all those things yet, but there are concerns if I'm using a black box and if something bad happens. How do I make sure that I test it out and I kind of make sure that the model actually says it's doing what it's supposed to do. So when you have all these challenges, there is also this notion of business model innovation. What can you do with all this amazing power and technology which is out there? Because you just don't want to do the kinds of things which you've been doing for the last 20, 30 years faster, better, and cheaper. Right? You want to think about, you can always squeeze more juice out of your R&D, but is that what you're looking for with all these amazing innovations? Right? So that's where kind of fintech is becoming more and more popular. There are a lot of innovations which are coming from a business model perspective, because user behavior is changing. The way in which information is being accessed, the way in which platforms are being accessed are changing, and that's where some of these emerging technologies, which we were just talking about, are making an impact. And solutions are not just technology driven. Just because you have machine learning and AI and all these cool technologies doesn't mean that you can get an amazing solution out of it. You need to be addressing it to a specific business problem, and you should be able to address it for a particular use case. So there are a lot of surveys which talk about where companies are investing, and obviously you'll always find like the major investments going into data analytics. From a platform perspective, people are interested in mobile and artificial intelligence and cybersecurity and kinds of things. But a lot of people are now thinking about blockchain, obviously, and trying to bring in some of these cooler identity management and biometric and cybersecurity aspects into the picture too. So let me kind of briefly talk a little bit about business models, because I'm kind of setting the stage for what could potentially be done with some of these solutions. Now, on the product side of things, you can always think about automation, right? So you can basically say, well, I can take a whole pipeline of how I'm doing things, identify the pain points in my pipeline, and I can automate those pieces so that I don't have to spend time doing those things, which is actually hogging up and it's not really value add. And I can let the systems take care of it, and I can focus my time doing other interesting aspects. And then you can think about unbundling, which is saying, well, there are potential business opportunities where you could say, traditionally this is how things were done. I can potentially come in and disintermediate and do certain things and add my own value at a cheaper cost. And that's what's happening with some of these robot advisors and some of these entities which are basically trying to build out new services. Now, there are a lot of interesting applications in here. What we are doing is there are these 8 facets we are looking at, which could potentially be thought of as the key areas where fintech is kind of making an impact. So there's payment processing, which is primarily, there are companies like Square. How many of you use Square or any of these platforms? A couple of them. So you have companies like Square, Toast, even companies like PayPal are trying to think about innovating and creating reward programs, and that's kind of causing some of the bigger players like MasterCard and Visa to question their business model on how they should be doing things. And wasn't there an article on LinkedIn about this big credit company which was trying to put all the credit card transactions on a blockchain? So then there's obviously blockchain. Anyone implementing blockchain in your enterprise? Okay, so a couple of you. So there are a lot of interesting products like Ethereum or Hyperledger, multi-chain. A lot of companies are now thinking of implementing blockchain-based solutions in your enterprise. Okay, so many of you have looked at trading and investments. Anyone looking at robo-advisories or robo-advisors? Okay, so a lot of traditional asset management had specific things which used to happen in specific ways, right? You had a particular fee, and each player was kind of going through the whole process, and you had to basically pay the fee for a particular service. And you had entities which was kind of specialized in doing specific things. Now you have robo-advisors, which are kind of questioning the whole business model, and that's kind of talking to a couple of people, and they were kind of thinking of, well, what if the fee is completely brought to zero? and we can capitalize on data. What in case we can potentially leverage alternate data sets and kind of make data as our business model rather than the actual fee for enabling certain transactions. So there are very interesting business models coming out on the robo-advisory side of things. And then there is, how many of you look at the tech report, which is, there's an analyst, Mary Meeker, so she actually releases a 200 plus slide deck and a video every year. So you should definitely make note, Mary Meeker. So she actually has an internet report, and every year she does an analysis of the trends in the industry. And there you can kind of get really amazing insights, because there are insights about the second biggest problem in tech is student debt. And there are a lot of initiatives on addressing student debt. And if you're looking at mobile as an investment, and obviously you know that there is saturation of the number of devices you can potentially sell. And now a lot of vendors are now thinking about, well, if you can't make money out of these devices, how can we add services? How can we capitalize on various platforms which are out there so we can engage the audience? Because a lot of content is now being delivered through mobile devices. And now it also goes into engagement, because all the services which was designed in the last 15 to 20 years, the millennial generation has to be rethought, because the millennials are not kind of investing in the same way traditional employees were investing in the context of 401ks and things like that. So there's a lot of thought being brought into planning and retirement planning, and I think Mass Challenge is going to have a fintech version through Pulse. There's going to be a Pulse Mass Challenge for fintech, and a lot of companies in the incubator will be working on some of these ideas. Okay, and then you have lending and insurance. I'm going to show you a case study on lending so you get a better idea. But then you have, as mentioned in some of the examples earlier, a lot of use cases on the insurance side of things too. I talked a little bit about big data, and there's obviously a lot of security-related applications. So I want to kind of give you, a focused pipeline approach to what is machine learning in general. When people talk about machine learning, what does it actually mean? And the kinds of things you're going to be learning along the way, at least the keywords, and how do you think about it as a whole process. Okay. So just because you learn Python doesn't make you a machine learning specialist. Just because you know how to use sklearn, which is a Python-based package, doesn't make you a machine learning specialist. And again, just because you can implement a deep learning algorithm with Keras doesn't make you a machine learning specialist. The key aspects of machine learning, is a whole thought process on how do you actually design these applications. It's not just about implementing an algorithm and getting results out of it. It's not just a piece of the pipeline. You have to automate certain things, but then also have a process on how do you actually work on some of these practices. So let me kind of summarize the key things you would do in building out a machine learning-based solution. Okay? And I'm going to go through step by step, and I kind of expand in certain areas on the kinds of things. How to do the time? 6:50. So I'll kind of spend like 15 to 20 minutes kind of giving you like the whole aspects on the kinds of things you would potentially do. And then how do you evaluate some of these algorithms? Okay. How many of you have built machine learning problems before, solutions before? Okay. Some of you have already built some of these things. And some of you are really new. So for people who are really new, just kind of focus on the big picture. Do not focus on the specifics, because I won't like you to kind of think of when someone says, here's a machine learning based solution, you should at least figure out like what aspects of it is their differentiator. Where are they really adding value? Is it on the data side of things? Is it on the process side of things? Is it on the evaluation side of things? How are they actually building out some of these algorithms? Okay. So when we talk about machine learning, I'm going to like focus on specific problems. I'm not going to go into all kinds of data sets. So you kind of know that when you have a data set, your data is typically represented, in rows and columns, right? So think of it as a basic Excel sheet, and you have a lot of variables because you are trying to estimate certain things, and you have certain observations you have collected in the past. And those could be numbers, those could be text-based flags, or those could be names like states or genders and things like that. Right? So this is how you're given or you have a particular data set. Now the question is, what am I trying to model? Right? So if you have variables which potentially could be categorical, which could be flags, some of this is like basic statistics, and then you could have like numerical-based numbers, bytes per gallon or salary or whatever you're trying to estimate. Now you could also have data sets where there is some kind of temporal continuity, especially in the financial setting. You have data sets which you're collecting on a regular basis, or it could be cross-sectional. Because the order does not matter. You are collecting a snapshot in time. How did Citigroup do? How did another company do? You're collecting various aspects. So when you're talking about machine learning, you have to first of all kind of understand your data really well, so that you can choose the appropriate technique. You can't just basically take, decide on a machine learning algorithm and then figure out what kind of data you have. You need to first understand the data set which you currently have, what format it is, can you modify it into a particular format so that you can apply specific algorithms. The biggest challenge my students face when I teach my class is most of the machine learning algorithms you study in textbooks are using cross-sectional data sets. And when they try to apply it in a financial setting, they look at, well, this is all temporal data. How do I kind of apply these aspects in a temporal setting? And what do I need to modify? And then that's where the challenge comes in, because now you're having all this portfolio of machine learning algorithms, and now you're looking at, well, I don't have those kinds of data sets. I don't have so many more features. I'm just collecting for each stock prices or returns or whatever I'm looking at. So I may not be able to use. I don't have a lot of factors to kind of make those kinds of decisions. So first of all, you need to have a landscape of your data. The second thing is questioning what are you trying to model, right? So this is where you have to kind of look at, well, am I just trying to, in the context of data science, all data science is not predictive learning. So when you are trying to build a data science solution, doesn't mean that you have to do some kind of a prediction. You are potentially summarizing certain numbers. You are potentially trying to extract certain bits of information and connecting certain pieces of information. You are potentially automating certain things. You are trying to summarize data which was collected in higher granularity into buckets. You're potentially trying to segment out certain things. You're potentially trying to create labels for the data you have collected. All those aspects are not prediction. Those are primarily trying to understand your data better, right? So a lot of descriptive statistics is primarily to look at the data you already have at hand, collecting, and it's primarily backward looking, and you're looking at various statistical techniques you can potentially apply. And you can potentially automate some of these aspects. And then comes most of the machine learning techniques, which are primarily used to forecast certain elements. You are potentially forecasting numbers or classes, or you're trying to build some kind of a reinforcement learning algorithm, where you're trying to build a recommendation. Those aspects are predictive in nature. So you will be trying to say, well, I will learn from my past data and then build a model so that if I get some new data in the future, I would like to predict something in the future. Right? So you need to be able to structure your goal on what am I trying to do. And based on that, you may or may not need a machine learning solution. Right? You may have to just think about a data processor. You may have to talk to your technology teams and say, you know what, I have all this data set, I just need to be able to summarize it in a particular format. It's not machine learning, it's just basically data summarization and some aspects of data processing. Now, the other aspect is, if I'm trying to understand, for example, in longitudinal data sets, you have to think about, well, I'm trying to extract certain aspects. I want to extract seasonality. I want to extract anomalies in my data set. Are there any cyclical aspects in the data? Are there trends in the data? So what am I trying to capture, and how much residual do I have? And do I have any more juice in my residual, or do I need to pass the residuals into another algorithm and figure out if there are things which I can capture in my residuals? So Larry, you were probably telling me about the ARIMA problems. I know you can, how much is there in the residuals, especially if there are intersects. So the context of machine learning, you can potentially think about two basic problems. Right? One is, given a set of variables, I want to be able to predict a class or I want to be able to predict a number. Right? If I'm trying to predict a class, it would be called as a classification problem. So things like I'm going to be going online, putting in a bunch of information, my salary, my work experience, the amount of loans I currently have, and at the end I click a button saying, can I get a credit card? And basically it goes through an algorithm, and then based on potential defaults a company can take, it may come back saying, well, based on your information, we can give you a credit card with these characteristics, or we'll deny you a credit card. Right? So it's a binary decision, or it could be multi-class. It could potentially say, I'll give you a card of a particular category because of your credentials. The other thing is a prediction problem wherein I'm going into a mortgage lending platform and putting in all my credentials, my FICO scores, my salary, my obligations, and then I'm saying I want a loan for $200,000. What will be my interest rate? And then the algorithm is going to go through all the potential defaults and come up with a number saying, well, I can give you a 4.7 or a 4.8 based on the number, based on the information you're given. Right? So if you talk to traditional mortgage brokers, so they'll have all these tabular data sheets, and they'll basically look up, oh, this is your FICO score range, and this is the table we get every morning, and we'll kind of go through this whole grid, and we will tell you where your interest rate is going to be based on all the information we have collected. Right? A machine learning based solution will learn from past behaviors on all the people who have been paying back their loans and what were their credentials when they applied for a loan, and what is the potential default rate, economic aspects, current interest rates, all those factors taken into consideration, and you can predict a particular interest rate. And if you can figure out like what the confidence level is, and if you are confident enough that is a particular number, and you could potentially give it out to your clients, or you could say, well, we have to talk to you. We need to engage a human because the algorithm is not giving you the result. Right. On the context of time series, again, you have to think about, well, I'm going to be modeling the future. When I first built my time series algorithm, when I was not familiar with all the aspects of time series modeling, I was always thinking, well, how can I model all these seasonalities? What kind of parameters are there? How do I specify the cyclical aspects in my data set? Right? And there are a lot of interesting algorithms, in the traditional time series world, ARMA, REMA kinds of models, GARP models. You can factor in voluntary clustering, and you can build very interesting models. And in the time series side of things, you are basically giving many more degrees of freedom. And you're basically saying that you don't have to restrict yourselves to these AR parameters, these PQs, or these specific kinds of models. You can potentially kind of learn from the various regimes, which has happened in the past, and generalize it to these kinds of algorithms. Usual kind of a thing, so you decide your goal, whether you're doing descriptive statistics or predictive analytics. So if you have cross-sectional data, what are you trying to do in terms of summarization? If you're trying to do predictive analytics, if you have cross-sectional data, what are the kinds of things you can do, segmentation or classification and prediction, or if you're time series things, what do you got? So let's briefly talk a little bit about machine learning algorithms. I'm just going to speed through it because we won't be able to kind of do justice to any one of these algorithms. I'm just going to give you like a big picture. So that's why I'm going to just focus on one segment, because the summer school is going to go through all the various techniques, but we'll kind of focus on specific ones. So we'll just kind of simplify the problem by saying, you have a bunch of variables, x1, x2, x3. We need a model, which is going to map my y to my x1, x2, x3. So what's that model going to be, right? So if my y is numeric, I'll call it as a prediction model. If my y is categorical, I'll call it as a classification model. Okay? So in the unsupervised side of things, what we typically do is we basically say, here's a bucket of data, and I have a lot of variables I've observed. I just need to be able to take my observations and bucket them into different buckets. I'm going to be doing clustering, right? Or I could think about, well, there are so many variables out there, and I do not want to be working with so many variables. And I reduce the number of variables. And that's where concepts like PCA comes in, where you can potentially reduce and do dimension reduction. So depending on your goal, you can work with interesting problems. So in the context when you think about, well, now I want to build a supervised learning algorithm, so you have various choices. So there you have to think about, well, do I want to build a parametric model, wherein I'm going to be thinking my output in the model will be a bunch of parameters, or some kind of a non-parametric model, wherein I can define the process and let the data learn from the process I've set up. So to give you a little more kind of context, so think of a parametric model as a regression model. So you're all familiar with it. You have a bunch of x values, and you need to compute your intercepts and your coefficients, and you use a technique, OLS or whatever it could be, and you are basically coming up with a bunch of parameters. So when you think about it from a machine learning context, you're looking at maybe even a neural network, wherein there are many more parameters you need to estimate. And the process itself can't be like a one-step kind of thing. You have to make assumptions on what those weights and biases are going to be. And then you have your outcomes. And then you're mapping your outcomes to the inputs. And then you need to kind of do back propagation, which is a technique to figure out how do I take the errors and then propagate it back so that I can tweak my weights and biases. Okay. So it's a heuristic which you're kind of trying to do. And there are intelligent techniques in which you're using to kind of tweak your weights and biases so that you can get your algorithm to map your outputs to your specific weights. So if you're looking at non-parametric models, then you're basically saying, well, if I'm using, let's say, a simple k nearest neighbor, I'm going to say, you know what, I don't know anything about my model. I don't know any parameters. I would say if my characteristics are very similar to someone I've seen before, then the y would be approximately equal to what my would be. So I'm just going to estimate the outcome based on the observations I've seen closer to me. And k defines the number of observations. So I could say, give me like the 3 closest neighbors, and then what's the y going to be based on my 3 closest neighbors, and then I'm going to estimate my outputs. So yes, please.
For the k nearest neighbors, if the k is equal to your sample size, so it is actually equal to the linear regression.
Yeah, there are some nuances with all these algorithms, which are like specific details. We'll kind of skip some of those details. So you can kind of extend these algorithms with multiple variables, the multilinear context, and you can potentially say, well, if I'm building a classification engine, I need to think about mapping my my numeric output to a class, and that's where you have aspects like logistic regression, and in the neural network case, you have to think about mapping functions. You have to map those outputs. So the point I'm trying to make is, when you're talking about machine learning, it's not just like a single black box. You have to contextualize it in a very rigorous way to choose your data set, to choose your goals, to choose your specific kind of an algorithm, and also the kinds of algorithms you can potentially use. I had a client who wanted me to use a machine learning algorithm so that they can predict their energy usage in the future. And they asked us to kind of compare multiple algorithms and come up with the best algorithm and justify why it was the best algorithm. So we benchmarked random forest, regression, neural networks, and those were like the top 3. And neural networks was the best algorithm. And we said, like, you should implement neural networks because based on all the historical data we have looked at, it gives you like the best error metrics, and you should be going with it. And they looked at it and said, you're going to choose regression. And so regression has like, the performance parameters of regression is worse compared to neural networks. Why do you want to choose regression instead? I want interpretable parameters. I want to be able to look at the influence of the temperature on my outcome. I want to be able to look at the influence of this particular parameter on my outcome. And I use my human intelligence to figure out like whether that's acceptable or not. So I'm still using machine learning, but I'm using a suboptimal machine learning technique just because the business wants to make decisions based on interpretability. So that's where you have to look at the trade-offs of using an algorithm which can give you potentially better results, but at the cost of interpretability, or you can use certain simpler algorithms where you can get interpretable results, but you may have to sacrifice accuracy and other metrics. So there are other aspects like unsupervised learning algorithms, where you can potentially take observations and say, okay, based on these observations, I can cluster or do interesting things. There are a bunch of different algorithms. I'm going to skip some of the details, but the most popular one is what's called as a k-means algorithm. And the point there being, we're going to use distance metrics. So if I find that there are parameters which are close to each other, then I do my pairwise distance, and I compare all my pairwise distance, and I find that there are a bunch of neighbors which are all close to me, then potentially those all should be in the same bucket. Okay? So that's what you can kind of see. If I just look at like a two-dimensional space, and I compute my parametric distances between these points, all the red ones are more or less close, all the blue ones are more or less close, and all the green ones are more or less close if I compute the pairwise distances. So, and you automate the whole thing. And you basically say, I don't know the labels, but if I have the various parameters, I can potentially kind of run algorithms so that I can bucket them into different classes. And now I have labels, because label generation is hard. And in order to do label generation, we either need to involve humans. Let's think of the simple task. If I have images and I want to classify those images, and I don't have a technique, I need to engage humans. And they have to look at each observation and put those labels. And here, if I'm automating some of it, so that I can bucket them into classes, and then I can learn from the data for individual classes. So there are aspects you need to think about, and there again, you had to kind of go into details about what a Euclidean distance is, or what a Manhattan distance is. If you're driven in New York, you just need to figure out what's the grid, then get there. If you're walking, you just need to say 34th and 5th, and you know how to get there. You just need to follow a grid. It's not like walking in Boston, right? You need to remember all your state names and all your, So, and then again, there are aspects of, distance functions, correlation functions you can potentially use for understanding the data is correlated. So as you can see, the decision tree is kind of growing, right? So when you think about machine learning, you have to think about whether it's supervised or unsupervised, whether you're doing a prediction or a classification. Now you have to think about whether it's a parametric or non-parametric. Now you have to think about which kind of an algorithm you're going to be using. So it's not a very simple decision-making process, but that's where you kind of build expertise as you work with these kinds of algorithms more and more, right? So once you structure the whole thing, and then you can potentially say, I can bucket them into the specific problems. I'm trying to do certain things, and I'm narrowing it down to a set of algorithms I want to experiment with, and then think about optimization, right? Now, the process is the most interesting piece, and when people talk about data science, this is what they're talking about. The whole thing starts with, I'm getting my data, I need to clean my data, I need to extract the features which I can potentially work with. Then I have to go through this whole process of training and testing, right? That's kind of new in machine learning, because typically what you do in statistics is you start with the data you have, and in the past, that data was also huge. I could not work with all my data. So what I would do is I would collect a sample, and then build a model based on that sample, and then figure out, can I generalize the model I built to my population? And if I can, then I'm going to use the model I've built based on the sample as my model. So here, from a process perspective in machine learning, you basically say, I'm going to take my data, I'm going to split it, build a model with data sets which I have, and then the model will be tested on the data which was never used. The model has never seen a part of the data. And then if my model works well for the data it hasn't seen before, then I can generalize that this model is going to be a good model for predictive tasks. Right? So you have to go through this process of training and testing. And once that's done, you have to think about all these parameters. Each model comes with a lot of levers. So you have to figure out what is the best combination of levers and parameters and hyperparameters. You have to go through this whole process of tuning, and then figure out once you have built the model, this is the best regression model I can build. I've done stepwise selection. I've done forward search, backward search, whatever algorithms I can potentially do in the context of regression. Or if I'm looking at deep learning algorithm, I've tried out all these different architectures. This is the best architecture. So you build out your family of models, and then figure out which model do I select based on all the models I have. Right? And once I can build out the whole thing, then I'm going to say I'm going to deploy this model. So the whole data science process is to kind of understand what all is done. And now ask yourselves a question. If you've never done machine learning before, will just learning Python get you all these skills? Okay. learning Python is the starter. Right? So you had to kind of come with the perspective of there's a whole process involved. And the second aspect is you need to figure out where you are going to be most influential in this whole process. Right? A lot of technologists come to our workshops because they figure out a lot of business users are asking them to do a lot of things which are data cleansing, feature engineering, building out infrastructure for training and testing. You don't want to be using your expensive data scientists. A data scientist is a misnomer. A data scientist is basically a generic class given to skills which potentially has to be a team of potential people who have different expertise. Right? So a data scientist on the data engineering side is going to be focusing on data cleansing, feature engineering, automating some of these things, scraping, putting it into a database, morphing the data, and doing all the things which are required so that a model builder can potentially take and then start building interesting models, figuring out the cross-validation aspects, figuring out the best model selection, and then the quant is going to come at the end. Once you have all the models, to figure out which model should I be using for decision making. Does it make sense to use this outcome in a particular context? Can I use it for trading? Can I use it for my investment decision making? Right? So there's no point in trying to have one person do the whole thing. That's where you have to kind of model the whole pipeline. So I'm going to skip through some of these details because it starts getting very dense. But the key point to remember is you're taking the data, you're splitting it into training and testing, and you build out your models, and then you need to figure out how do I evaluate whether my models are good or bad. Right? So that's where performance evaluation comes into play. So you have to think about what are the different ways in which you can evaluate your models. So in the context of supervised learning algorithms, it's not just good enough to look at a fit. So this data, I have seen, and my model actually gives you the best fit. You have to think about, well, what is my root mean squared error? What is my mean absolute percentage error? What is my mean absolute error? Depending on the context, you have to quantify some of these error metrics so that you know what kind of errors could potentially be there. Right? So for the example I was kind of discussing before, the energy trading case, the metric was mean absolute percentage error. They had algorithms where they could go from 5 to 10%, and they were saying that if I can get something better than 5%, it's okay for us. And neural networks was giving us 3%. Regression was giving us the best regression algorithm we had was 4.8%. But it was less than their threshold. They said there was a business decision that less than 5 is good, and 4.8 was still okay because their current algorithms, which kind of was a hodgepodge of different techniques, was giving them something 8 or 9% and was not replicable to. So you have to decide what your metric is so that you can start choosing those algorithms. And that's where you have to think about tuning, because you build out your algorithm, and this algorithm, as you know, is not going to be working forever, because after a couple of days or a couple of months or whatever your horizon is, you can realize that your model doesn't work anymore, and then you have to fine-tune your algorithm. You have to think about parameter tuning again, so that you can get to the next set of parameters which can potentially be used based on the new concepts you have learned and generalize it for the new concepts you have learned. Telling you, if it was a binary case or a yes or a no, how many of the true yeses could I model accurately? So if I have a lot of diagonal elements, a lot of numbers which are in my diagonal elements and my off-diagonal elements are 0, then I have a really good model, right? But it's also going to tell me, how balanced my classes are. And that's where you need to start structuring problems, because all classification problems are not the same, right? If it's a credit card decision-making problem, you could say, I accept 40% of my clients will potentially be offered a credit card, and 60% will potentially be denied. Right? But think of it about machine learning-based fraud detection algorithm. Right? How many frauds do we observe in transactions? Very few. 99% of the transactions are legitimate transactions, but the 1% are the ones which you need to model. The machine learning algorithm should be fine-tuned so that it can detect the 1% of those fraudulent transactions at the cost of having a lot more false positives. That's why you get a lot of calls from your bank which tells you hey, you may be, what are you doing in Florida? You were in Boston couple of hours ago, and then you will probably call them back and say, yeah, I just flew in Florida, that's why I'm trying to make a transaction here. I mean, these systems are also getting smarter, but that's where geospatial analytics, aspects of your own past behavior, that's where your temporal aspects come in. I mean, like when I got my first credit card, I had a limit of $500 as a student. And then, when I got employed and I, got my first, I had the same credit card and I had to fly to California and I made my first 500 plus transaction, and it was kind of, they had up my credit limit to like $800 at that point. And I was above the threshold. It was a rule-based system and it blocked my transaction saying, hey, you're going more than 500, you've never gone more than a couple of $100, so what's happening kind of thing. And then it learns from your own behavior that, oh, this person does frequent $500 transactions, so even if your neighbor is caught with the similar transaction as a fraudulent one, your transaction will kind of pass. Right? So you're learning as you go from your own perspective, but there are also like systemic aspects that, if there are a lot of transactions coming from a particular IP address, or if a lot of transactions are coming up with similar purchases, you need to block those transactions. So these algorithms, then it starts becoming tricky, because if you're having an anomaly detection or an outlier detection kind of a problem, it's still a classification problem, but you can't just use a generic classification algorithm and then apply it in the context of anomaly detection. So you have to model it in a particular way. You have to model those outliers. You have to model those anomalies so that you are able to kind of detect those rare class or unbalanced problems. And then there are all these accuracy measures you have to kind of be familiar with. What are the error rates? What's the accuracy rate? And then you need to be able to interpret your ROC curves, and you have to look at sensitivities and specificities. So this is where I would like to take a pause. As machine, as someone, if you're a quant or if you're in the financial industry and if you're trying to implement machine learning, I would start backwards, in the sense that I would not start learning to code in Python and get to a point where I can generate my own confusion matrices and interpret those and make decisions. I'm going to start backwards. Start from interpreting these models. Start from choosing the best possible models, figuring out which algorithms give you the best performance results, and then figure out what skill sets you need so that you can bring in the right kinds of technologists who can write the best code. Right? I worked at MathWorks for more than 5 years, but I could not, compete with my MATLAB, engineers who were writing MATLAB for like 20 plus years. Anything I would write with like 15 lines of code, they could write it in like 3 or 4, because they were really good at optimizing the code and figuring out what's the best way to write the code. So if someone tells you, if you want to learn machine learning, you just need to start with learning Python, that's really wrong advice. Okay, so you need to start out with understanding the whole pipeline, the process, where your value add is, and understanding what algorithms can potentially help you, and then figure out where your gaps are and build out your talent pipeline so you can get the best view. Otherwise, you're never going to be able to compete with the smart machine learning folks out there who also know to recruit the right kinds of people and implement those systems. Right? You will have a suboptimal machine learning algorithm, but that's absolutely useless. Right? Your traditional techniques may be better off rather than just choosing suboptimal ways in which you're going to do things. Okay? So beware. If someone says they're going to teach you big data, fintech, Python, machine learning, all in like a week, they're lying. They just want their pots and they're kind of running away, including us. Don't give it to us. So here's kind of, like as I kind of started with the agenda, there are all these parameters you need to be aware of when you're building out a machine learning pipeline. And this is where you're going to do yourselves a favor by understanding the process first, and then focusing on where you would want to bring in value as an enterprise. Right? You could potentially build a product which could leverage all your data cleansing techniques or all data processing techniques and optimize it, and that could potentially give you a huge business boost. Or you could think about, well, our traditional algorithms having so many errors, and if you can benchmark an algorithm which can do better than your traditional algorithms, you can potentially implement those. Right? Or it could just be the way in which you request a service. There are a lot of these machine learning as a service kind of platforms. You can try it out and figure out whether they actually can work for your particular use case, and then kind of build out your platform. Okay, so we kind of looked at handling data. We talked about what your goals could be. here are all the potential machine learning algorithms you could potentially use, and then this is the process you need to be familiar with. Okay? And then this is like the evaluation framework, and how do you actually look at different algorithms and see how you can like potentially use different methods for evaluation. So I'll share the slide, but Azure actually has a nice algorithm cheat sheet, so you can kind of go through it and figure out like which algorithm you can potentially use for a particular use case. But the point is, there are a couple of things you need to be aware of as a financial professional. First of all, understand that it's not a generic solution. You have to contextualize machine learning for the business problem you have at hand. You can't just basically, the machine learning is better than what I'm currently doing. It has to be a specific match for what you're doing. Otherwise, you're going to be looking for the needle in the haystack. Okay. Secondly, you should not be deploying all your prototype models. Quants know that. But the key thing is, just because you have a little bit of data and your model works for your little bit of data, you can't just deploy it into production because things can go bad very, very fast. So you have to do a lot of testing. All these are data-driven algorithms. I had a student who was recruited by this amazing startup. I don't know the name specifically. It's a healthcare startup. And my student showed all the results he had done in the class, and they wanted a machine learning approach to their data analysis, and they wanted to recruit him. And unfortunately, all their scientists were healthcare scientists. They had absolutely no clue on machine learning. And the student wanted advice, so I met with them and started asking questions. And then I said, well, this company hasn't started trials yet. So do they have historical data? I said, no, they don't have any historical data. And they want to use machine learning. So how can you learn when you don't have data? Right? So you have to really have the right kinds of data sets so that you can use it. Otherwise, you won't be able to learn from something you don't have. And then there are aspects, this was some of the quotes from there was a panel in HVAC and Society in Iran. So they were all of them were talking about their production problems and trying it works beautifully when we do a POC, but when we try to deploy it in production, it doesn't really get the value. Then other aspects are, there is a lot of, it's still not a proven science yet. Some aspects of interpretability and auditability of model, that's very important, and transparency of the code base. It depends on where you're sourcing your models, especially if you are leveraging a third-party entity which provides you just the data and says they're using machine learning to build those data sets. You need to have ways in which you can test out those data sets, and you need to have the right kinds of skills to be able to even evaluate those algorithms. And then, claims like machine learning models are more accurate than traditional models. That's all bonus. Depends on what's the metric and how are you benchmarking, right? You know how to compare refrigerators at a Home Depot, and just whenever you see the specification, you see all these grids of potential parameters, but you need to focus on the ones which matter to you. Just because one had a bigger list compared to the other doesn't mean that it's better. But you need to also know which parameters are important and then rank those appropriately. And then there's all this hype about well, AI is going to automate the whole thing. We are just scratching the surface. And there are a bunch of white papers from UC Berkeley. Michael Jordan, who is one of pioneers in AI, not the basketball player. Michael Jordan is a professor at UC Berkeley. And some of his students are amazing. Some of the MIT professors here are students, and also Andrew Ng, who is a very famous machine learning researcher, was Michael Jordan's student. So he actually has a really nice white paper on AI and the state of the art in AI. So I would recommend that you read it so that you kind of understand that we are not there yet. To kind of automate the whole thing and just buy the hype and make things possible. Okay, how are we doing with time? So we're very close to the end. So what I'm going to do is just kind of, I'm not going to show you code. I'll kind of give you the code so that you can try it on your own. But let me just kind of talk about some of the kinds of problems which could be interesting if you're trying to set up a machine learning experiment, and especially in the financial context, and you want to try out certain things. One is a credit risk problem. So if you're trying to figure out credit scoring models, there are traditional models which have been put out by various credit rating agencies. So a lot of companies are now trying to build out fintech platforms on building out things based on a data approach. So historically, people were using gut feel or 500 years ago. So if you are in the community, if you know the lender, or if you can vouch for a friend that you can lend this person, people would say, okay, I'll give you the loan. But then the traditional mechanisms like credit bureaus they have their own assessment and business rules. But there are newer places like peer-to-peer marketplaces. One of them, which is very popular, is Lending Club. So they actually have done a good job in kind of giving away data sets which could potentially be used for modeling. So it's like real people applying for loans and what loans were actually funded by peers and at what rate. So you could use those real data sets for learning, and you could try and build an estimator. If a person comes with a particular profile, what would be the potential interest rate you want to give? And you can try out interesting things. So I'll share a Python file with you if you're interested, and you can kind of play around with it. So that's one problem you can potentially use. I've kind of given you like how would you kind of go about the whole thing if you are interested in just kind of taking a process-based approach and then implementing your own. But I can also share some of the code we have written on your own. Another one is segmenting stocks. So you can potentially just get returns, and then you can build out like a clustering algorithm and see how stocks which are similar can behave similarly. And then you can build out clustering algorithms and figure out whether those form kind of clusters. And I'll show you an example. So we actually ran an algorithm. So this one. So we had like a bunch of different stocks. It was kind of a historic data set from 2003 to 2008. We ran this clustering algorithm, and you can see, some of these companies like CVS and Walgreens are all in this first bucket, and then SAP, IBM, HP, Xerox, IBM, Amazon, Cisco were all in one bucket, and then Northrop Grumman, Lockheed Martin, Raytheon, General Dynamics were all in one bucket. ConocoPhillips, Total, Exxon, Valero Energy was all in one bucket. Honda, Mitsubishi, Sony, Canon, Toyota, all in one bucket. Pfizer, Novartis, GlaxoSmithKline, all in one bucket. And then Kraft Foods, Kellogg, Pepsi, Colgate Palmolive in one bucket. Goldman Sachs, Bank of America, Citigroup, Wells Fargo, etc. in one bucket. So you can kind of see like the automatic bucketing based on their return characteristics. Nothing else was given to the algorithm, just their return data and their price return, which is converted into return data. So companies behave differently, but similar companies behave similarly. Is kind of the system. Okay? So that's another case study, and you can also potentially build out something. There's like obviously the event trading example. Another case is obviously there was a breach in protocol recently about the jobs report, but if you had not, if you were an event trader and you were looking for the jobs report number and you had built all your models, figuring out that this number is going to come at a particular time, and if you had missed out on this tweet a couple of hours ago, you missed out on an opportunity, right? So, event traders would potentially be interested in tweets now. If they are looking for job reports, I'm pretty sure event traders looking for job reports as one of the economic indicators, which is going to lead them to make trading decisions, will be looking for specific kinds of tweets at least a couple of hours ago. It's going to come or not the next time, but at least they're going to be looking for those kinds of tweets. Okay, so we're going to have a case study in the NLP workshop, which is happening on, so this is actually a road slide, sorry. This is, the dates have changed. It's July 11th and 10th and 11th. And I don't think we have time for the Q sandbox. I'm just going to give you a quick demo. This is what we've been building. So we have codified some of our best practices and build out this platform called as a research hub. Just a second. So basically, when you come to this workshop, Okay, so you can actually look at all these workshops. So you'll have all the specific sessions, the videos associated with that, the video notes, yeah, and then the link to the Q sandbox, which is still in beta. So basically, what we have done is we have codified all these experiments in some of these machine learning experiments, and you have all these things you can just basically click. So you have we have a partnership with MathWorks because I used to work there and I knew some of the people there. We're also engaging some of the data vendors and kind of creating experiments. So the point is, you can codify some of these things and try out machine learning experiments without having to start from scratch. Installing all the packages, kind of configuring all the required environments, and building out everything from scratch. So we have codified the whole thing, and this is where we're spending a lot of our efforts on. And the nice thing is you can run concurrent experiments, so you can run multiple experiments. All these are running on the cloud. So if you wanted to run a simple experiment, so you could basically choose what experiment you want to run. And there are a lot of projects in here. So if I wanted to look at, so there's one here. So here's some R experiments, some Python experiments. So you could potentially choose what you want to run and choose where you want to run. Everything's running just with the browser. You don't have to kind of put anything or install anything on your machine. So you can choose what you want to run on, and then you can specify how many hours you want to run the experiment for. And then this becomes like a platform for data scientists and quants who do not want to kind of think about where do we get the data, how do we configure the whole environment, what installs do we need to use, do we need to use GPUs and everything. It just becomes like a form you can select. And then once it's done, you can basically, it's going to take a little bit of time because we're kind of doing cold starting here. We should have started before, but the point is, in many of our workshops, we have experiments kind of sitting, case studies sitting with some of these sessions we're going to go through. So that way you can basically focus on the specific case study rather than kind of doing the whole installation configuration. You don't have to write Python code. Everything's going to be written. You have to just kind of work through the specifics and understand what actually happens when you run those experiments. Okay. So that's that. So by the time it kind of moves up, I'm going to share the last few pieces. So we have some aspects of integration with your code bases so that all your quants in a particular company can focus on a particular distribution rather than each one having their own installs. You know the problem, right? Like, if everyone has their own Python installations, everyone having their own R installations, it becomes a challenge to kind of reconcile once it's been built. So you can specify aspect there are the command line interfaces. You can automate. So once you have built your model and deployed it, you can just put it like a cron job or schedule it so that you can run on a regular basis. Some aspects of IT administration in terms of what your credentials are for cloud or what your credentials are for various source control systems can be put in. And then you can kind of manage various tasks. You can say, I want to run this experiment, I want to extend the lab for a particular time. So you can audit like who's doing what experiments, and you can share those experiments with various groups. And in the course of time, we are using this at Northeastern University for the courses I teach, so that basically students, rather than focusing on installation configuration and looking at the IT-specific tasks, they can focus on the data science and machine learning specific tasks on what analysis we can do with various algorithms. So that's a little bit about the platform, and we currently have Amazon and Google support, and we're working on integrating Azure. So you can see that the algorithm right now it's running. So let's see. So this one's going to be running for the next 57 minutes. So now you can just going to launch a Jupyter notebook. So now it is, right now this is kind of running on the cloud. So this is like, we didn't have to do any install, we just had to choose a particular experiment, and this particular experiment is, this is what you would typically do. It's a Jupyter notebook for people who we've used this before. So this is basically a cut-fold reinforcement learning algorithm, and then you can kind of play the video and see how the experiment was kind of performed. Okay. So you basically have a whole running environment within a couple of minutes, and you can kind of start and stop, and then you can audit all the experiments you've been doing, and you can stop and restart with more infrastructure. You can also go into the terminal and you can specify what parameters or installations you want to do. So typically quants have a problem of reconciling all their models, and I mean, like I was talking to one of the people, she's not here, but the context of auditability of models and what models can potentially be deployed, and the whole model life cycle, and where did you start, what assumptions did you make, because there's a whole process involved. It's not just the model at the end. How do you kind of build out all these components and audit each one of them, so that when you have your whole pipeline, if something bad happens, you'll be able to figure out where it happened and how can you rectify that particular problem. So we've built in all those logs and auditability on the back end. We can potentially go and look at the so that's a little bit about the thing. And if you're interested, just go to qsandbox.com and put in a request. We're going to do a private beta in the next month and a half or so. We'll get back to you on that. And the last thing I want to say is we are doing our first summer school in Boston on data science on 26th, 27th, and 28th July. So it's going to be a 3-day intensive bootcamp style learning of data science and machine learning. We'll kind of go through each box in the pipeline, kind of build out algorithms. Our goal is not to make you proficient Python coders at the end of these 3 days. At the end of these 3 days, if you're able to take a look at a particular problem, ask the right questions, and figure out what kind of an algorithm it was and what are the things you should be looking for when you build out these algorithms, I think our purpose is served, and you should use that as a learning objective so that you can start enhancing your skills and building your own experiments and contextualize it in your own business practices and bring those practices into your workplace. Okay? So note the dates. It's going to be 26th, 27th, and 28th. And if you're interested, just go to analyticscertificate.com. All we're still working on the details, and send us a note. We'll put you on a list and we'll send you the application process and how we can go through it. Okay? So I'll stop at this point, and if there are any questions, I'll take them up. Thank you.